In this tutorial, I'd like to look at solving systems of linear inequalities. Alright, so let's start with a real basic system. Let's start with y is greater than or equal to x. Y is greater than or equal to x. And let's look at y is less than, strictly less than, negative x. Okay, so there's our system right there. Okay, so this is our system, these two simple inequalities. Alright, so what we're going to want to do is graph these individually. Okay, so, oops, that's not very straight. So we'll do a real simple graph here. Put a few marks on here to help us. Alright, now let's graph this first one, y is greater than or equal to x. And really what we want to do is treat this kind of like graphing y equals x. Okay, y equals x. So this is in y equals mx plus b form. It's just the plus b is a 0. This is a 0. So our y-intercept is right here at 0. Alright? And then, of course, this is an implied 1 here, so this is like 1 over 1 for the slope. So it's just up 1 and over 1 and up 1 and over 1, up 1 and over 1, get a few points there. Alright? And then we draw a line through here, and I'll do my best. Draw a line through here. Okay. And that's the graph of y equals x. It's a 45-degree line going through the origin. Now, this line right here is y equals x. But when we have an inequality like this, we have to shade either above the line or below the line, because it's all those values will make this true, all these coordinate points here, anywhere either above or below. So we need to determine which ones. Well, there's a nice little trick when you have these equations solved for y. When it's a greater than, when this alligator here is eating the y, then you shade above. When it's the other way, when it's less than, the y is less than, you shade below. So in this case, it's greater than, and you shade above the line. And the other thing I want to make note of is, since this has an equals to, it's a greater than or equals to, this line is solid. Okay, just like we have it. But when there's no equals, like this one, it'll be a dashed line. Okay, so that means points on the line, when there's an equal to, points on the line are also solutions. Okay, they're the solutions to this. Alright, so we're going to go back and we're going to shade, and I just kind of say, I just put some marks saying I'm going to shade above the line like this. It's a little easier to shade on the paper, but I'm just going to shade like that. See, my shading is all up here. Alright, now let's graph the other line. Well, it is y, we want to treat this kind of like y equals, to graph it, y equals negative x, and graph that, but remember, this is strictly less than, so it will be a dashed line. Okay, but we want to follow that y equals mx plus b format. Our b's is 0 in this case, so again, our y-intercept is here at 0. Okay, and now we have a slope of negative 1. So that's like negative 1 over 1, or we could write that, so that's m equals, or that's 1 over negative 1, either way. So if we look at it this way, it's up 1 and left 1. So I'm going to do that, up 1 and left 1, up 1 and left 1, get a couple points with a little distance. And we can look at this one as well, and that's that's going to be down 1 and right 1. Down 1 and right 1. Okay, so they both work, they both fall on the line. And so this is our dashed line, and I'll do my best to draw a line through here. This is my dashed line going through those points. Okay, the arrow's on the end here. Okay, now this one is less than, so we're going to shade below the line. Okay, it's a nice little trick. When this is less than, when y is less than, you shade below the line. Okay, now the actual solutions to this system here are in the overlap, any points here in the overlap. And you can see the only overlap is this area right here. Okay, so let's look, it's like the overlap, you know, the red part is here, the green is here, so here's the overlap. Here, over in here, this is just red, the solutions to the red line. Over here, there isn't any solutions. There's no shading here at all. And here is solutions to just the green. But here we got solutions to the green, and we have solutions to the red. So these here, these are our solutions. That's kind of simulating my shading, okay? These are the solutions. So right there is the solution set. Any point we pick. Now we could test that. We can test that out by picking any point over here. So like, what's a point over here? I don't know. Here's one I see. It looks like right on the line there. That's 1, 2, 3. It's -3. -3, 0 is this point right here. It's -3, 0. Okay, so according to the shading here, that should be a solution to these inequalities. All right, so let's look at the first one. Y is greater than or equal to x. If I plug in a -3 where there's an x, -3, leaving this part the same, and plug in a 0 for y, 0 is 0 greater than or equal to -3. Is that true? Well, yes, 0 is greater than -3. That is true. So this checks out, this point checks out for this one. And we could check over here in this one. Okay, so that one is y is less than -x. That's the red one. Okay, that's this one right here. So again, we can see if this point is a solution to this other one. So -3 for x, so -3, okay, is greater than y. Y is a 0. 0. Okay, so now simplify 0 greater than, well, negative, you know, that's like a -1 times -3, or a +3. Is 0 less than 3? Well, that is also true, and it works. It checks out, this point checks out, check, check, both true, and that looks good. Just to look, you know, we could look at over here at some point here, like maybe like 1 negative, if I go over 1, so over 1 and then down 3. So to that point right there, and that's 1, -3. According to the shading, that should only satisfy this red equation. Okay, so let's look at it. Yeah, so it's the red equation, or the red, it's not equation, sorry, the red inequality is y equals -x. Okay, so we'll plug, this is 1, -3, so we're going to plug in a -3 for y less than -1. Is -3 less than -1? Is that true? According to the shading here, it should be. And -3 is less than -1. That's true. Okay, that is true. All right. Now, if we put that same point into the green, it should not pass. It should not pass the test. Okay, so, oops, that kind of disappeared here, but let's look. So that green inequality is y is greater than or equal to x. So let's put this point in here. Oh, sorry, not that one. Let's put this point in. So negative 3 greater than or equal to 1. Is that true? That is not true. Negative 3 is not greater than 1. That's false. And that was what we predicted. We predicted that this point here, at this point, wouldn't pass the test of the green, and it doesn't. Only points that are going to pass both this inequality, the red and the green, and the green inequality, are these points, any point over here, like that point that we tested. Okay? So that's a nice simple one. Let's look at something just a little more difficult. Alright, so let me hide this one. Let's go to this next one. Alright, now, here we have y is strictly greater than 2x plus 1. So again, we want to graph this as if it was y equals 2x plus 1, kind of using that same graphing method, the y-intercept method. But of course, this is strictly greater than, so it'll be a dashed line. So we go to the y-intercept, it's 1. So go up to 1 and go ahead and put a dot. I already had the graph set up here. And then this is the slope, and it's really like 2 over 1. So it's from this point, it's going to be up 2 and to the right 1. Let's go up 2 again and to the right 1 more. Get another point. And really we could count down 2 and to the left 1 as well. Down 2 and to the left 1. Okay. And then those points, and this will be a dashed line, a line through those points. Okay, and that's not the best job, I know, but it's not too bad. That's a dashed line. It's supposed to be a perfectly straight line. It's a little crooked, but that's okay. Get the idea. And then we want to look at the shading, and since this is y is greater than, we know that the shading is going to go this way. So I just indicate it like this. My shading's going to go like this. My it's going to shade above the line. Let's graph the red line. Remember, the overlap of the two is going to be our solution set. Alright, so again, we want to look at the y-intercept. It's down at negative 2. There it is. And then now, this is like negative 1 over 1. That's an implied 1 in there. Okay, so it's like m equals negative 1 over 1 or equals 1 over negative 1. You can use either one of those. Okay, so I'm going to go up 1 and left 1, and up 1 and left 1, and up 1 and left 1, and get a little bit of distance there, and that's not too bad. And again, this is a dashed line also because it's strictly less than. So I'm going to do my best here, dashed line through this. Ooh, getting off just a little bit. Okay, not too bad. Put arrows on the end. Okay, that's an arrow. Okay, and there's our line. And now this one is less than. Strictly less than. So dot dash line. And less than means I shade this way. Okay, I shade below the line. And now we look for the overlap. Okay, where is that overlap? Okay, and well, here we only have solutions to the yellow inequality. Here we don't have solutions to either one, nothing here. Right in this area, of course the lines are our boundaries. So right in here, this is only solutions to the red. But here I have solutions to the yellow and solutions to the red. So here are my solutions. Here's my shading, so to speak. Right here. Here's where all my solutions are. Forever and ever this way, okay? With this line as a boundary and that line as a boundary. Right? And so there's my solution set. Right? Let's look at one last one. Okay, so I'm going to hide this one. And, oops, there it is. I'm going to have to bring this up just a little bit. Okay? And now we have this blue one and we have this green one, and these ones aren't solved for y, and you can still graph them and pick a point and shade them that way, but I think it'd be just as easy to go ahead and move things around and solve for y. So I'm going to move everything over and get just y all by itself on the left. So I'm going to add, actually I'm going to go back. Okay, I'm going to use a different color. I'm going to add 2x to turn that to 0. And this thing's having trouble writing. And then, so if I add 2x here, I have to add 2x out here. Okay. So add 2x, both sides. That leaves me with, let's go back here. That leaves me with 4y is greater than 2x plus 12. 4y is greater than 2x plus 12. Okay, now my pen's having a little trouble here. Okay, so now I'm going to divide each one by 4. Okay, I'm going to divide, and maybe I'll go back. Maybe I'll go back and do it in the other color. Okay, so I'm going to divide each of these by 4 because I want a 1 right here. I want 1y. That's y. So 4 over 4 is 1, and that's going to leave me with y is greater than 1/2, because 2 over 4 is 1/2 x, and we can bring that x out front, plus 12 divided by 4 is 3. And so I've solved it. Okay, I can go ahead and graph it now. That's strictly greater than. So it's going to be a dashed line. I can graph this. So at 3, 1, 2, 3, that's my y-intercept. And here I go up 1 and over 2. So up 1 and over 2. Or I can go down 1 and to the left 2. Okay, something like that. So down 1 and to the left. Oops. Down 1 and to the left 1, 2. Okay, that's pretty close. This dot's off a little bit. It should be over. Okay, and then a line through those that's dashed. Okay, through all those points that's dashed. So there it is. Arrow, arrow, there's my dashed line. Alright, and then we say, okay, so y is greater than, so that's a shade above. So we're going to shade above. Okay, now we got that one done. We need to come over here to the green one. Alright, so we're going to come over to the green one. Now, I want to do the same thing. I want to get y on the left side. So I'm going to add 3x to both sides. Okay, that'll turn this to 0. It'll put 3x, whatever I do one side I do to the other. And that leaves me with 6y, okay, greater than, strictly greater than, so this will be a dashed line also, 6y greater than 3x minus 12. And we want to put the x term first, because then it's in the y equals, we want it in that y equals mx plus b form, except for instead of equals here, it's an inequality. Okay, it's a greater than. Alright, now we're going to go ahead, we want y by itself, so I'm going to divide by 6. I'm going to divide, hopefully you guessed that. I'm going to divide by 6. Alright, that turns this to a 1 right here. That's y is greater than, and 3 over 6 is 1/2. 1/2 x, okay, that x can come out front, minus, and 12 divided by 6 is 2. Alright, so we go down to negative 2. There it is. And we're going to go up 1 and over 2. Up 1 and over 2. Okay, and that's a pretty good distance right there. Okay, we could also go down one and to the left too. Right? Now we draw a dashed line. It should be a straight line. It's not looking real great, but I'll do my best. That should be on the line. Dash line through there. That should be a straight line with a ruler. It's a little hard to do on this, but okay. So there's our line. And then, and honestly, this has the same slope, a 1/2 and a 1/2. So these lines should be perfectly parallel. And my drawing's off just a hair, but they should be perfectly parallel. So y is greater than, so we're going to shade, and this is, it'll work though. This is going to work. This should shade above. And so you can see there's nothing, there's no solutions to anything down below. There's solutions to the green, you know, in here, all the way here. And then we start to get solutions for the blue once we get past this dashed line. These are solutions to the blue here. But these arrows, these green arrows, are actually going to go on there. That arrow means forever, so they're going to go on this way. You know, they're going to go on. Those solutions, that shading is going to keep going. And so the overlap is actually, you know, in here. So, you know, starting just past that dashed line. So you can say the dashed line and on, you know, all this on, this is our shaded region. This is our solution sets out here all the way up to, but not including the dashed line. Okay, so that would be it. You would graph this real nicely, or you would shade this real nicely on your paper right here. Make this dashed line clear that it's dashed, clearly that that's dashed, and that would be the solution set. And that's it for this video. Thank you.